Good evening, everyone. So today we will see regression models, and yeah. So what we what we saw yesterday, central tendency. So I believe sheet number mm, ah, box plot central tendency. Okay, yeah. In central tendency, I'm just recap, just to revise for just one or 2 minutes. Central tendency. There are in three metrics when we are measuring the central tendency. One is mean, median, and mode. And mean is the average of all the values, all the data points, and divided by the number of data points, we will get the central tendency. Second, median, we will get the middle middle point of that data point. And third is mode, which is most frequent data point. That is called the mode. And in this way, we can find the mean, median, mode. In normal distribution, all the points mean, median, mode will come. All the points will come in the same axis. Distribution is how the data points are distributed in our sample. So if left side more data points are more concentrated on means all the data points are more, it is not more deviated, but in right side the deviation are more. It is not all points are near the mean, median, mode area. It is little, they have some uh, variance, they have some deviation, so that's the reason it is. And now we are there are two type of standard deviation. One is sample standard deviation, and second is population standard deviation. Sample, it is n minus 1, and divide and calculate the distance from average, from all the data points, from the average to all the data points, square divided by sum of all the squares and divided by the n minus 1. It is simple. And n is when we are not using sample data, when we are using the actual data, so that time it is divided by the n. Variance and standard deviation, there is no such difference. It is when we are not square root, when we are not doing a square root, we are just square the value, it is variance. And again, the variance are two types: sample variance and population variance. Now the regression point. Wonderful. Today is the actual discussion for regression. I believe everyone wants to know these things. Regression, what is regression? Regression is a form of predictive modeling technique. Means it is a form of predicting modeling technique which investigate the relation between dependent and independent variable. Very good. Means the relation between independent and dependent, means there are two type of data usually you will get. One one which have dependent variable, and which and another one will have dependent variable. So how we can decide which one is independent and dependent variable? I am giving you one very generic example. like rash driving and number of accident. So rash driving is a independent variable, and why it is independent? Because it is not dependent on anything, and it is a cause. And number of accident, it is dependent. It is effect, cause and effect. So whatever is cause, it will come under independent variable, and whatever the effect after cause, whatever the effect, cause and effect, so it will come under y y category. It was under coming under dependent variable. So we are we are mentioning dependent variable in x-axis, independent axis, independent variable we are considering is as a x variable, and dependent we are considering as a y axis. So like that. Here we can see here one more example, like the salary and experience. Salary is totally dependent on the experience. So whatever the salary, whatever the dependent. So salary. So year of experience is independent variable. It is considering under x variable, and salary. Okay, one more thing. Today discussion will be purely theoretical, and maybe Monday also half, not half, mm, because after Monday onwards we will go purely on we will see the statistical modeling with Python coding. So bear with us, because these ground level of working is more important for all of people, because I can't do directly regression models on code only, because little idea you people should have that what we are going to do and why we are doing it. So that's the reason I am just teaching today a little theoretical. So please sorry, but uh, I can't do without knowing these things. So everybody should know, and it is very interesting topic and little boring because little theoretical, and sometimes you people will not understand, because if anybody don't have background statistical, so but you will enjoy. I believe you will. I will help you to little ground level work, and once we will go for the purely coding, then you will, whatever the doubt, all the doubts will complete. So today just listen carefully. So I'm just trying to give you a small example so that it will helpful. Like the year of experience. Okay, so year of experience and salary. So year of experience is considering under a independent variable, because when year of experience is growing, salary is growing, or when year of experience is going down, means less experience, salary is also less. It depends. I'm not saying when we are going on data science or machine learning, maybe it will more. So, uh, so in this case, uh, advantage 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 is the relation between dependent variable uh, and independent variable. The in this regression model, it is an advantage that we can find out the relation between dependent variable and independent variable. So okay, now the second point is what kind of regression technique we will use. We will use the regression techniques are depend on three metrics. Please carefully understand. Regression technique are depend on three metrics. One is what we understand, independent variable. So it depends on the number of independent variables. So how many number of independent variables we are using into regression, means suppose uh, we have a equation, and in this equation we have number of x variables, number of in number of independent variables are there. So it depends on the how many independent variables we are using in in regression model, it also dependent. It is also depend on the regression metrics um, and second is shape of the regression model. It also depend on the what kind of shape we are using. Shape means we are going for the linear regression model, or we are going polynomial regression model, logistic regression. So what regression model, its shape also depend on the regression also. Shape of regression model also depends on the regression technique. And type of dependent variable. So what type of variable, the type of independent variable. So uh, it is also depend on the type variable, which type of independent variable we are using it. But generally it is depending on the first two only: how many independent variables and shape of models. This is the first two techniques are for dependent on three metrics. So regression techniques are depend on three metrics: for number of independent variable and shape of regression model. Okay. Now we are going to see here little more with graphs so that it will understand more. Linear regression. So as it is, the name is linear, means it is a kind of straight line. So linear regression is first model which everybody is using in data science or statistics. It is linear regression model, so it is very popular. And here we will found um, uh, there are the two type of variable. There are the two type of variables. One is dependent, another is independent. Dependent is y-axis, and independent is x-axis. And so you can see that there is one straight line is here. So one straight line, uh, one straight line is here. This straight line is a regression model line. So regression line is here in this, and and the dot point are the blue dot points are the our data points. So which are near the regression line, which are near the regression. So the model, suppose we have a one regression line and model and data points are near the models only, so we can say this model is very good. So there are so many formulas are available so that anyone can understand which model is suitable. But in general, as a because we till now we did not saw any formula, so we can say that okay, this line is somehow it is better because most of the points data points are near the regression line only. So somehow we can say that okay, there are few points like this point is a little outside, this point is little outside, but the rest of all the points are near the regression line. So regression line means it is a predicted line, predictive value. And a blue point is blue point is dot is actual values. So regression line means predicted. So predicted means from the we doing via machine learning models, we will generate some predictive line. We will generate the predictive line. Those predictive lines, and data points are actually, these are the this straight line is actually a predictive line, and data point is blue line. So most of the points are near the predictive line, so we can say this is good line. And second is we are creating this line via using modeling technique. Okay, so yeah. Now here in regression line, we found this is a straight diagonal line, and here we found that 1.0 and 2.0, 1.51, 1.3, 30, 2.25. Actually, these are the data points, and these data points, how much distance they have from the actual position. So, we are calculating the distance because all the data points should be very much nearby the regression line. It should not be far. So idea behind is most of the data point should be near either they should fall on the regression line, or if data points are not falling on the regression line, at least it should be near the regression line. So the formula which is mentioned here, xw minus y. Xw minus y means xw is the, you can understand in this way that xw is the regression line, and we are calculating the data point. So sum up the difference from the regression line minus data point difference of the line, and square, because why square? Because if we will square it, the magnitude become positive. If suppose few points are above of the regression line, definitely those points distance are positive, but those who are below the regression line, it will consider as a negative. But as a statistical modeling, we consider only positive values. So that's the reason it is square, and sum up all the square. So sum up all the square value and try to minimize the square value, minimize the square plus some value. So that's the reason we are considering the model which have a less data, distance should be less. And two values we are counting for which model is best. uh, First is r square value, and second is adjusted r square value. So in this way we are considering which model is better, so which model, because so in future we will see, not now, don't worry. Today we are not going to see anything on via Python code, and but you people will see those terminology which I am writing right. I'm speaking right now. But that day you will see that where is r square value, or where is r adjusted r square values. So via two values we are considering which variable we should consider it. And for model performance, these two metrics are very much important. One is r square value, and another is adjusted r square values. So we'll see. So don't worry, just listen carefully that what I am speaking. And second is, uh, here in when we are considering the linear regression model, I already told there are two type of variables will available in regression model. One is dependent, and another one is independent. Dependent means y points, and independent means x points. So if suppose we have a x point, I'm just suppose we can consider, uh, sorry, uh, sorry, this control jet should, suppose we have uh, three independent variables, x1, x2, x3. So if three independent variables, if all the three independent variables should be ideally there should not be any relation between x1, x2 and x3. Means all the three independent variables should be independent only. There should not be any relation in between x1, x2 and x3. All data points should work independently. There should not be any effect of x1 to x2, or x1 to x3, so there should not be any relation. So if any data point, if any independent variable have some relation between x1 or x2 or x1 or x3, so that is called the multicollinearity. So what is mentioned here, in multiple regression suffer with the multicollinearity. Multicollinearity means they have some relation between this variable, have some relation between in this variable or in this variable. So they are internally they are interrelated. So that kind of attribute is called the multicollinearity. So the data should not have multicollinearity, but ideally it is happening. We found that few data which have this kind of attribute, and it is not, in general it is coming under multi-regression, multiple regression. Now the autocorrection. Autocorrection, what is autocorrection? For example, in a class, in a class, we have in a class 50 students are, and in 50 students we are going to collect the all the students record, all the students subject marks in first semester, second semester and third semesters. So when we are collecting first semester mark sheet of all the students, and then again after 3 month or 4 month after, again we are going to collect the next semester mark sheets, next semester marks. So when we are calculating the values or data with certain period, with over the period, so definitely those records have some correlation between previous data and current data. So that type of data is called the autocorrelations. Means that over the suppose after 3 months and 4 months we are going to again collect the data. So definitely there should be some relation between the previous record and current record. Same student have a, suppose in maths he got the score in 65. Now he will not get the 95 record in this period. Again he is a kind of 65% guy, so definitely he will get the 67 or 75%, but there should not be 99%. Well, ideally I'm not saying that maybe it will happen, but it is a kind of relation. Like uh, in general, most of the record will be correlated data. So that is called the autocorrelation. Autocorrelation is coming under when over the period we are getting some records. Thus, we are collecting the same record. We found some there. They have some relation between the previous and current record. Some relation. And heteroscedasticity. What is heteroscedasticity? Name is little difficult. Heteroscedasticity is it is not here. It should be here. Okay. Heteroscedasticity. There are two type of heteroscedasticity. Suppose x and y coordinate. We know the Cartesian plane, and in Cartesian plane, x-axis and y-axis. So uh, in Cartesian plane, when we are incrementing the value of x in k, and the same time when we are incrementing the x value, it is also incrementing the y-axis also, y values also, then it is called the homoscedasticity. But the thing is, the proportional, it is proportionally it is increasing. It is not like there are some variance, like you can see in the first graph, homoscedasticity. We are seeing here that the when we are incrementing the value of x, y value is also incrementing. But in the second graph, heteroscedasticity, when we are incrementing the x value, y is increasing, but y is diversing. Y have a some drifting. You know, so it is not going like it is along the same proportion. It is drifting the value towards outside, and that is called the that kind of attribute is called the heteroscedasticity. So if we have a sample of data, whatever we are talking about here, we are trying to know the characteristic of data samples, how the sample's behavior is. So maybe one time sample behavior is homoscedasticity, another sample have some heteroscedasticity. So heteroscedasticity have some y is drifting more, means value is not only increasing, the values have some variance, more variance also. So giving some example, like we are calculating wages. So when wage equal to alpha plus beta into experience plus u. Alpha and u is the constant, alpha and u are the variable, but experience. So when we are calculating the wages, year of experience multiplied beta, and there is some additional values which is sum up with the experience. So it is drifting. So y value is not coming just proportionally, it is coming little more. So that's the reason it is diverse outside. So it is one of example. It is not the only example. So, so this is the linear regression attributes, multi-collinearity. You said understand autocorrelation and heteroscedasticity. There is one more. Sorry, I just okay. So what we did, what we see here, linear regression and linear regression. There are three attributes: multi-collinearity, autocorrelation, and third is heteroscedasticity. Now the linear regression, we are in a linear regression, you will find when you will check the records, you will find the three and four type of data you will find about the sample. So whatever we are talking about, we are talking about the sample details. So when we will check in linear regression, we will find some term coefficient, standard error, um, t values, and p greater than t values. So I will explain what is the p greater than t values. It is just to understand this. When we will get this data, what is the meaning of it? Is meaning is when we are incrementing, when just so that the table show the intercept is intercept means y-axis. It is meaning of this this value, and I'm just considering very traditional. Yeah, y equal to mx plus c. M is the slope, and c is the intercept. Okay, sorry. So this is linear regression, and this is the intercept value. It is considering 0 comma c. Okay, so intercept value, the coefficient is every whatever that values will be here, every value have a some coefficient. So intercept value is minus 114.326. We have this formula, this data is just for one sample record. It is nowhere it is related. We will find only this record. It is just a sample record. So we just try to understand what is the meaning of this record values. The table show that the intercept is minus 11432 means minus means it will cut here. It is not on above this record is so And why? Because it is below, so it is a minus C. Okay. And height is 106. So understand the what is the meaning of height. Height coefficient. Height coefficient is 105.505 plus minus 1155. So it is a difference of these two lines. Means if we are incrementing each unit of x increases, we can affect y will increase 1065. So it means when we are increasing one value of one unit of x, um, it will increase it will increase 1.106 106.5 value of height will increase. So whatever the coefficient is mentioned here means when we are increasing the one value of x, it will increase the 106.505 times height will increase. Suppose 2 value will increase, 2 into 106.505 value will increase. Okay. And what is the meaning of p type and type? P is the significant coefficient. Significant coefficient value we will understand in future, but today it is little theoretical. So p value is 0.05. So
Hey,
it
hi Manish. Hello.
yeah,
Hey
yeah,
Manish, sorry for disturbing.
no problem.
Hey, I think if you go continuously on theoretical, right, people will get bored, I guess. And not bored. I mean, once we get into practical things, we again repeat the same theoretical concept. That's why what I just suggest is, so better you give some theoretical and as well give practical. That's what that is better. I feel.
No,
But
no,
I don't know about others.
I understand your point is very correct. But problem
Yeah.
is, I'm just creating a background. Even I'm not teaching multiple class only
Uh-huh.
theoretical,
Yeah.
but
No.
this class is
No. That's
somehow theoretical.
Yeah, no, what I feel is even if you continuously read and go, right? So
Haha.
what will happen? We just hear and we can't memory everything. So what I feel is like if you give some steps as well in the data wise, that will be very good and help others also. That's what I feel. I don't
No,
know
no, no,
about others.
you're somehow you are true. I understand the even I will
Yeah.
also feel the same thing. But the
Yeah. No,
problem in
what my side is whatever you are telling, I'm just hearing as some thing news like that. So that's what I feel. So I don't know about others.
Yeah, no, no,
So maybe
you're right. I understand, but problem is that little in statistics,
yeah.
we have to bear in this class. Next class, I will
Okay.
next class onwards. I already. That's the reason I'm not giving my more input on theoretical. So this class only, little bear up with me.
Yeah,
Why?
sure.
Because
Okay.
I will just foundation. I will just give some foundation so that when I will teach with coding, because in coding we have to again explain more. So that's the
Yeah,
reason
that's true. That's
I
what
want to fast that period.
I feel. The coding wise, right? With the coding wise also, again, we have to give the same knowledge to everybody. So that's why I'm asking you. Maybe it's better to give elder
Ha ha.
time
Correct.
maybe.
Correct. 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 I
Yeah.
will. I
Yeah.
understand your point. I understand your point.
Yeah. Okay. Yeah, you can continue, man. Yeah.
Okay.
Thank you. Anyway, you have planned for something, right? So you continue for the same thing. Yeah.
No, no, no. You're true. 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 I agree. I agreed with you.
Yeah.
I agreed. I agree.
Okay. Yeah.
So
Thank you. Yeah.
please mute somebody. I think. Okay, good, good. So don't worry. This is the only class for today only. It is little theoretical. I agreed that even I have no interest with the theoretical. But this is the problem in this data science. We need some background. We need some background because we are not coming from a statistical background. We all are have some mathematics background because my is personally mathematics background. I never studied earlier any statistics, so just making a foundation, because when the foundation will little, so that when I will talk some p value or t values or uh, so you people will little understand. Okay, yeah, we little idea about it. But if I will go for programmatically only, so because most of the time you people will go for the job also, they will not expect you will write the code only. They will expect that you should know little idea about the theory also. But theory is not important. But theory is only important to understand the thing. And this is the only class. I am very much sorry. This is the only class I will teach little theoretical, but later on it will be totally purely coding only. I'm not interested for theoretical. So this is the only class. Okay. And no, it is okay. I understand. They are the theoretical question. Yeah, true. Because why? Because and what I'm trying to help you. mm, Uh, when because most of the thing when I will teach, I will complete in a one day. One regression will complete. So you will feel that I will not take any additional time. Which other are teaching, but I will take one day, one regression model we will complete, and in theoretical also. But this class is just I'm just aggregating everything. So please, multiple regression line. So multiple regression line, it is a regression line when we have a multiple x1 and x2 value, x1 value and x2 value, and error is the last coefficient is it's called under coefficient of error. So it is and here we will find the same kind of matrix, we will get it, but here is more, one more is width. So the only difference is multiple regression line, and I can't show multiple regression line because it is more variables are here. We can see only the two dimensional, but here you will find width, height, and width. So when we are increasing 1 unit of width, understand, it is a very tricky thing. So if we are increasing, height is mentioned 106.505 and width is 994.56. So it is mentioned here when we are increasing 1 unit of width, 1 unit of width, height is increasing 94.56. Ideally we can think that it should be increased 106.505, but why will increase 94.56? So you can just think in this way. So I'm just this is the multiple regression line, and the formula is uh, y equal to mx plus c, but here is more data points are there, more x1 x2 variables are there. So beta 1 x1, beta 2 x2 plus so we are clubbing all the independent variables here. Ordinal value we already explained. I'm again repeating it again. Ordinal value are the distance from the data point. A regression line, the distance from the data point, and regression line. So that is called the ordinal least square. Why least means sum of all the data points from distance from the data point and regression line, square value, plus sum of all the points, and the sum up should not be should not more, it should be least value. That's the reason it is called the ordinal least square value. Ordinal least square value, it should be the distance should be less. Uh, okay. So it is I already explained, it is repeated, like but I am explaining you, this is a very interesting point here. You people will uh, just see again. Linear regression means linear means straight line. Okay. So in linear, suppose we have a I'm running one a pizza factory, and I'm a pizza manufacturer. So when in pizza factory, the price of pizza is depend on how much cheese I am using, how much base cost is. So it depends on the two factors, two or three factors. When price is depend on topping, whatever the ingredient I'm using it, and second is base. So if price is increasing, it depends on when topping is increasing, when the price of ingredient is increasing, pizza price will increase. That I can consider. And R square value is 89%. Means 89% means 89% data points are falling are falling on the regression line. R square, what is the meaning of R square? Means the 89% data points are falling on regression line and 11% data points are not falling on regression line. That is so just understand the meaning. Now what we understand that the data points are falling on the regression line. Suppose we want to go for the little better performance. So what we did, we added the male or female data points are also on the regression line. So we are considering male and female also a variable, independent variable for this regression line. So whenever we are creating a regression line, we need to know we are considering more independent variables and one dependent variable. So more independent variables when we are considering, it increases the R square value. So understand the point. If we are increasing the independent variable, R square value will increase, but doesn't mean that whatever the uh, whatever the the independent variable we are including, it ideally it should be needed, because suppose male and female, which we are considering as an independent variable for this model, but pizza price will not increase if we are added male and female. But what we are found, R square value increased when we are when we added male or female variable. R square value increased. So it means even though model is saying that your R square value is more good, now it is 90%. Earlier it was 89% only. Means 89% data was falling. Now data points are falling 90%. So ideally this model should be good, but it is wrong, because we considered the wrong independent variable for this model. So it is very much needed. Means ideally we should, when we are adding more independent variable, we should be very careful. Those independent variables should not be useless. Otherwise what we are doing, we are just trying to overfitting the graph. We are just trying to get the more good R square number, so that our model should be good. Ideally it is wrong. R square, maybe it is more, but it doesn't mean that that model is good. So there is one more point is adjusted R square. We are considering that period, and adjusted R square is helping us to find the good model. So two variable, whenever we are talking in future, we will talk about the R square value, and second is adjusted R square value. So whenever you just remember the few points which I am talking more, because I am talking unnecessary more. So R square value and adjusted R square value. So R square, adjusted R square value, you will on that basis we will consider which model will suitable, which model have a variables are which variable we should consider, which variable should not be considered. So via R square value we will understand. And logistic regression. So logistic regression is where we are using the logistic regression. Logistic regression, when we have a two type, when we have either pass or fail type of record, 0 or 1, yes or no, success or failure, that kind of we have a data points. Means either data point is falling under 0, or either it is falling on 1. So you can see in this graph, most of the data points are either falling onto 0, or either it is on 1. So 1 means in probability it is either one person will come or one person will not come. So or it is fail or it is pass. So if it is fail, it means it is a 0 probability. If he will pass, that probability is 1. So in that basis we are considering the logistic regression. So in logistic regression, it is an exponential curve. This curve is exponential. It is a log curve. This is a log curve, and here is P is the probability of occurrence. Probability of occurrence. Probability we all people know. Again, I am saying probability means like probability is help. It is just a mathematics we studied. Uh, how much probability of anything, any event will occur. So that probability is a number of outcomes and favorable. So probability, I will. So total outcomes, for example, head and tail. So head is suppose in a coin, there are two faces. One is head and another is tail. So there are two possibility. So we are considering 2 points here. And what is the probability head will come if we are going to toss? So head count of head is one, and two probability two faces. So head and tail. So total number will be here, and the favorable outcome will be here. So so in this way we are counting any probability. Suppose in a dice we are playing early days we were playing Ludo. So that time we were using dice. So in dice, six faces, and suppose anybody will ask like, what is the probability one will come? So one in dice, one is one time only, and total outcomes are six. So one divided by six. Suppose we have a two dice. So what is the probability one will come? So one into six into one into six equal to one by 36. This is the probability of two dice, both dice will show one only. Or if we want two, so similarly, one dice have a two one time only. Second dice also two will be one time only. So one, it is also 1 upon 36. Okay. So that is the way I'm just trying to show that how we are calculating probability. But I believe everybody know the probability, as I am assuming. But don't worry, we will not calculate anything via via pen and paper. Everything will do by the formula, via some libraries are available. That's the reason we are interested in Python coding. All the scikit-learn is a very much popular. I will show, so you people will not think only theoretical. So I will just show you one thing. So it will sklearn. Yeah, this is so. You just see here, this library is very popular. This is the only library will help us to know all the things, means regressions, clustering. We are mentioning here, we saw here regression, clustering. Now we have a little idea about the regression when we are going for predictions. So that time we are using this clustering. If we are going for clustering, we are using this section. So but whatever the the either clustering or regression or classification will do, we will take help from the scikit-learn, sklearn. Yeah, so I pasted here. Okay, so in logistic regression, there are so many regression. So I will not consider all the regression, but I will consider today like few regression, so that at least logistic regression is very popular. Most of the companies will ask logistic regression, and it is this regression is considered under the classification. Classification means when we have a set of problems, so we are classifying this problem should fall on which type of category. So that time it is considered under classification problem. So you should understand logistic regression. Uh, and we are considering it is a no multicollinearity means there. Now very good question, now very good point. When you will understand, when you will read anytime, no multicollinearity means in between independent variable there should not be any relation, because these are the statistics keywords. So you people will always confuse. So understand the things. Multicollinearity means there should not be any relation between independent variables. Means like for example, I'm giving you a scenario in US. You all people know that when the salary is increasing, taxes is also increase. So even though tax and we have a formula, for example, we have a formula in this. Uh, for example, we have a formula in this beta, beta naught, beta 1, and this is our salary part, and beta 3 is the part of our tax. Suppose we have a formula, this formula. So S and T, even though these are the independent variable, tax have a different column, salary have a different column, but it is 100% these two variables are interrelated, multicollinear. So this is the one of example which is popular. So if any data have some relations, so it is not allowing in logistic regressions. So the data should not have any relation. Okay. So just understand these things. I know that just reading this way, we will understand everything. We will just try to understand and remember only thing. Logistic regression, linear regression, multiple linear regression, what is multicollinearity, what is autocorrelation. So these terminologies you just remember, because we are just going for a long journey in data science, and data science is very vast, very difficult if we are not knowing these terminologies. So please understand these things. Polynomial regression is a curve which have some more power of x, like y equal to b naught, b1 x, b2 x2, b3 x3, bn xn. Means x keep now here is the power of x is more than one. Then we are considering polynomial regression models. So when we have a power more than one, it is considered under polynomial regression. So just to understand this graph, when we have a problem, some set of problems, and we consider first graph is linear regression, second is polynomial curve, and third is overfitted curve. So we have a data points. Red points are data points, and blue line is a predictive line. This blue line is the curve line. This is the in this way. So when we suppose I created one predicted model, and that predicted model fall under first category. So what you can understand, okay, few data point left side is missed, few data point are not fitted on right side also. So we can consider it is underfitted. It is not fitted properly. Okay, in this way we can consider. Now the second is, oh, second is, if suppose your model is fall under second category, you can consider, okay, good, it is consider more data points we are covering. So that is good, very good. But in third, in this way we are created the model, which is totally rubbish, because we should not overfit. We should not cover all the data points, because when we are covering all the data points, means we are trying to force our model in such a way that it should fully packed, but ideally it is not it is not fully fitted. We are using unnecessary argument, unnecessary variables, independent variables, we are using it, which is not suitable. So the best suitable first and third is not considerable. Only second is considered. Even though third is somehow capture more the data points, but ideal situation it is third model is not acceptable. Only the middle, which one is even though few data points missed, but it is considered a good data point, because in future when we are going for predictions, new data point will come. Definitely that data point will near the regression line, near the resolution is. So B is good. Suppose in third, suppose new data point will come. So again, curve will not understand, because curve just learn the thing according to the current data point only. So second is best model. So whenever we will see the graph, we will tell nowadays, we will tell from today onwards we'll say model. Earlier we were saying graphs. Now in future we will say model. Okay. So again, the regression model are three types of regression. Is stepwise regression is count uh, three type. One is standard regression, forward regression, and backward regression. So uh, standard regression is when we are creating a model. For example, when we are creating a model, so there is few steps. So I'm just showing you in this stepwise. In stepwise, sorry, uh, stand, yeah, is a standard regression here. Uh, when we are creating a model, that time when we are suppose we selected one independent variable, then again we will add one more model. We will think that okay, this independent variable will again useful. Then suppose 4 5 independent variable we selected, then we removed one independent variable. We think that okay, this have a less r square value, or adjusted r square value is more, so we consider or we remove. So in this way we are using the standard regression. But the second way of doing the standard regression, the stepwise regression model, which is forward regression, means when we consider one time one variable, then then second step again we are consider one more variable. Third step is again consider one more independent variable. So we are moving forward means step by step we are considering, we are adding more significant variables. So to find out the which model will suitable, which model will help, is giving more r square value and more adjusted r square value. So in this way we are moving forward value. These all three are the technique. And third is the backward elimination, backward selection means we consider one time we selected all the independent variables, and step by step we are removing. Okay, we consider, suppose we have a four independent variables. So what we are doing in the model, suppose we have a ax1, sorry, ax1, bx2, cx3. So when we are seeing that we have a three variables and a three, and we consider in our regression model all the three variable we consider, and one by one we are removing. Suppose this variable is not useful, we remove this, and then we found the next step, we found that this variable is not useful, we removed it. So in backward integration, we in a starting point, we can suppose I'm a very new guy in data scientist, and we got the job to create the regression model. So that time we have no idea like which variable we should consider, which variable we should not consider. So the best approach is consider all the variables and step by step remove the variable. So it is more useful. And so backward selection is very useful technique. Now the second point is regularization technique. So in regularization technique, there are two techniques are available. One is ridge regression, another is loss regression. So just understand, it is not we will use in future also. It is just to understand. Two techniques are more useful. It is very popular. Most of the companies are asking regularization technique, so you people should know these things. So regularization technique is using when we have a multicollinearity. When the data is suppose we have a data which is multicollinear. So what technique you will use? So because we are not considering in linear regression or logistic regression, these kind of multicollinear data. So if suppose we have a multicollinear data, means independent variable have a some relation. So that period we are using ridge, ridge regression model and Laos regression. So ridge is considering under L2 type of regression, and Laos is considering under L1 regression. So they have some mechanism. The way it is the software or library is doing it, but in general we should understand in this way. Laos is L1 type of regression for regularization, and Ridge is L2 type of regularization, and both have a same purpose if data have some multicollinear. Internally they are related, some they have some relation between the x variables. But in elastic regression both are considering Laos plus ridge. So it is a combination of, you can say in this way, it is a combination of Laos plus ridge regression both. So I'm just doing little fast so that I will not bore you people. Um, and regularization, it is a three type of regularization is there. One is L2, L1, and elastic curve. I just copy paste here when I, because I did not found any diagram, so I just L1 form is a circular form. L1 form, just to understand, it is you people, because you people have to show in your in front of company or in front of your senior to senior managers, like you people have a little depth knowledge, and this will helpful because nobody know very much about these things. L1 form is a circular. When we have a beta 1, beta 2, beta 3, these are the coefficient of equation. These are the b1, beta 1, beta 2, beta 3 are the coefficient. And suppose it is considered, it is a L1 type of regularization. So L1 type of regulation it means it is a circular type of means coefficient are on circular format. And L2 form, it means it is a cardinal, means it is a diagonal type of, you will find it is a diamond shape. Beta 1 is diagonal, and again you will see one more on bottom and here. So it is a kind of a diagonal type. So L1 is considered Laos, L2 is considered Ridge, and elastic net regularization is considering Laos plus Ridge both. So I'm just giving you one small example so that you people will can understand. For example, one person have some salary money, and this is tax or it is the error. Epsilon is always error. So it depends on the actually data are correlated because I already discussed that this second variable and third variable are interrelated. That's the reason we are considering into regularization technique. You always remember regularization technique are always using when we have a multi-collinear data. So in this situation, when we have a money tax or something, you can consider the company's performance on sales. Suppose we have a sales record or sales record or taxes or GST. So suppose we have this type of bigger data set and we are considering into independent variable. So we should understand in this way. We should analyze the data, how data type is, and if it is interrelated, so we should use a regularization technique we should use, and which regulation technique we have to use, we can see, but in general we are not using it. So we should just theoretically we should understand this thing only. Okay, I just given you the sample one chart. Like ridge is circular and it is Laos is coming under little this type of graph. Okay, forget about all these things because little more theoretical. Uh, Now we consider we have a three type of linear regression. One is simple linear regression, another is multiple regression, and third one is polynomial. Simple regression is simple line straight line equation. So B naught is the intercept point, B1 x1. Multiple regression line have a multiple independent variables. So x1, x2, x3. So these it will also generate. It will also create a multiple linear regression, um, but it will not be a straight line. It will a different type of shape. Polynomial, it is a parabolic curve because here you can see x1, x1, x1. The variable is constant, but variable have a power more than one. So that's the reason it is parabolic curve or it is a polynomial curve. So the graph shape is different, and it will little steepness will be there. Like for example, we can count salary and experience. So salary and experience, it is considered under polynomial curve. But let's see, we are not assuming right now here. We can see in the polynomial curve in this way. Polynomial, why the linear is there? Everywhere we are considering the linear regression, multiple regression, polynomial regression because the the library which we will use, it is falling under linear regression only. Either it is polynomial, but it is a family of linear regression only. Simple regression also have a same family. Multiple linear regression have a linear regression family, and polynomial also falling under the linear regression. Even the library which we will use, it is also a linear regression library only, and it is and library is available here. Here, so we will see. Next class we will see everything. So here is B naught B1 x1, and um, it is a parabolic curve. Now, very interesting thing we should see. There are two type of supervised learning and unsupervised learning. So, anybody have an idea like what is the supervised learning and unsupervised learning? Because I already showed here. So, supervised learning means when we have a data. For example, I'm just explaining myself. Suppose we have a data and data is already labeled data. Labeled data means suppose I am teaching to a kid. This is apple, this is banana, and this is another example. Or we are trying to teach in a students like these are the kind of animals, and this animal is elephant, this is dog, this is cat. So we are categorizing the data and labeling the data. This kind of element, this kind of animal is dog, this kind of animal is element, this kind of animal is fish. So we are not just showing the data, we are labeling the data. So when we will ask the kid, like, okay, please tell me what of this element, this new new animal. So because kid know that we can know about the category of data, so he will use use his brain, and he will tell, okay, this is not duck, this is dog. So like for example, here is duck, not duck, not duck. So suppose I will show some dog photo here. So definitely he know that okay, duck have some mouth is different type. So if I will use dog here, so definitely he will say that, okay, no, 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 this is not dog, because this is not duck, this is a dog, this is a different label. He will not understand the name of the label, but he can say that this is not dog, this is not duck. So that is called the supervised labeling. Supervised labeling is considered when we have a data with labeled data. We have a data, and that data is under format of labeled category. So that type of learning is called the supervised learning. So data is already in a labeled format. Means every data have a set of data, and a set of data is already saying this data is financial data, this data is uh, transactional, this is OLTP. Well, different type of data. This is a student data, this is admin data. So when we have a data, and that data is under certain category, that is called the label data, and from that model, from that data we are learning, it is called the supervised learning. So when we have a data, but it is not in labeled format, that is called the unsupervised learning. For example, I teach to kid, like okay, this is the photograph of animals, you can see. And here is a few, one element have a nose are different, and uh, and ears are different shape. So these are the one type of animal, and another have a small nose and small eyes. They are different type of animal. So we will teach to the we will teach the with the characteristic, we will teach the about the data to our system. Model means kid is a model, and we are teaching with the characteristic, like dog. We will not tell dog about the dog. We will just say that first, third, and fifth is a different type of animal, which and second and third are fourth are second and fourth are a different type of animal. So we will prepare the model in such a way. So like for example, we have a 10 million data, and 10 million we have no idea about what kind of data we have. So that time we are using unsupervised learning. So unsupervised learning, it is helping to know the about the data with the characteristic, with attributes. So that is called the unsupervised learning. So supervised learning, when we have already data into a labeled format, when data already in a category format. But unsupervised learning, we know that okay, this data is different, this data is different, this data is different, but we have no idea about which label it will fall. Either it will fall under dog, or it will fall under cat, because we have no labeled in unsupervised format learning. So this is the major difference in supervised and unsupervised. Unsupervised have no label. We have a category with attributes, we can easily understand it is a different kind of category, it is a different kind of category, but the name we have no idea. So now we are going for the realistic case study, so that we can understand. uh, uh, okay, Suman, sorry, I did not saw your message. Why the supervised and why unsupervised? This is the category of learning. There are two kind of category of learning of model. Okay, when we have some historical data, you can understand in this way. This case study will help us. Suppose we have a supervised learning. We have a historical data. So when we have a historical data, so definitely we already labeled the data. For example, we have a salary 2000, and 500, and along with the data we have his purchase status. Suppose 2000 data already purchased, sometimes 3000 salary guys also purchase data, purchase some item earlier, but 1500 these salary guide never purchase, and 5000 guys also. So in this way we have a data. So now the predictions are coming. Suppose we have a 1900 salary guys, so he will purchase or not. So we can easily find out with this formula, if guy's salary is more than 2000, equal to or greater than 2000, then he will purchase. So means our model can easily predict that, okay, this 1900 guy will not purchase the item based on the historical data. So we have a historical data, and we have a historical data, and that historical data is already labeled. We already found out the relation and formula. That time we are using a supervised learning. When we have a data, suppose we have a fresh newly startup company, and we have no as such record history, so that time we will go for the unsupervised learning, because we have only current requirement. We have no as such like who will purchase or who will not purchase. We have no as such idea about, because we have no because we our company is very new. So in that case, our system can only help us, like, okay, these are the high salaried guy, medium salaried guy, and low salaried guy. It can help us only that, but it will not be helpful set which one will purchase and which one will not purchase, because we have no as such previous record. So when we are going supervised learning and unsupervised learning, when we have a historical data and labeled data, so then that time we are going supervised learning. When we have no historical data, we have only requirement. That time we are going for but even though we are categorizing the data, we can easily categorize the data, but we can't label it. That time we are going unsupervised learning. So we will see that more case study on these things in future. Okay. So that's finished. Sorry. Today I I was speaking fully. Okay. So so next day we will start data processing and linear regression, as I will show you that what we will study in future class. This is overview PPT. Here, okay. So this is more interesting for all of us. Like statistics, I will complete today because I did not taken more time. Whenever statistics I will use along with the programming. I will hold it, and at the same time I will show. I will not separate class so that you people will not bore. Python I completed statics, so this already done. So from next class onwards, we will go for the data pre-processing, regressions. Then we will go for the simple regression, multi-regression, polynomial, SVM. These things one day we will take it time, and then decision tree, random forest. This I will show you. I will share you. And actually, why I'm not sharing because in this I'm adding so that it will be. But anyway, I will share. I will share today. I will share both. Here is you can see in this what we will go for the next class with data pre-processing. Next class we will simple regression. Then after next class we will go for the simple regression. So every day one regression model I will complete with whatever the theory is needed. I will complete. But you can understand in this way that you people have a little idea about the regression, so it will helpful in future because I need not to exhaust more energy that time. And after that decision tree will complete, and then random forest model performance, which model will more good, which will less. Then clustering, then k-mean clustering, hierarchical clustering, association rules, and these things. And apart of also I will little guide you like how the requirement is coming and how you will start thinking. I will not teach few things, but you people will can start doing because nowadays more popular is AWS also. So many companies have a data in AWS, so they are using it. But mm, you can side by side. Many articles are there, but first you people should know. Some only today only I did not use lab, but before that I was using lab only. So means lab means along with me, the next class onwards, everything is lab only. So here we can see here everything means except today. Next class onwards, everything is lab related only because Python we did everything. I showed on lab only. Statistics I can't do because statistics we need to know. Even I can give the PPT also, but I thought that at least I will teach little. So, but next class onwards, here next class means fourth onwards, data pre-processing till onwards means you will see everything practical. Okay, this is the only thing I want to tell you people. Okay, now the point is, what will be our next class? Next class is Saturday, Sunday. I will not. No, 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 no. Tomorrow is no class. I will not. I will not go for weekend class uh, because I have an engagement. So I will teach only on 5 days, 5 days in a week. So Monday means nee, nee, it is my ethics. So I don't want to. I want to give relax on myself only. Also, so Monday, Indian time, Monday, same time, we will go for the data pre-processing. So, these classes are very important, and I promise before time I will complete with full knowledge. With I'm not saying that you will become a data scientist master, but you can easily identify the problem. You can easily sit with us very senior guys and talk about the data science related things and talk about the modeling. Those things capability I will give you, and it totally depend on you people that how much you people are efforting with me. Whatever the Python code which I had given you, I will just suggest you people should go and type it again and again. And whatever the statistics today I taught, you just read it again and again. You just give me 1 month, one month, 10 days and 15 days. I promise I will give you at least 30%. I will make you 30 to 40% make you data scientist. 60% depend on you people. And this time it's best time because most of the guys are very new. Those who are taking your interview, they are also don't know many things. So it is the best time to enter. Otherwise, when they will know, it is very difficult. So you can n number of case study you can use it, and you can know the things very well in this period. So my personal suggestion is go for the Python, we discussed till now. In weekend you will go for read, use by a pen and paper only. And second, a small Python code you start like top 10, top 3, or reverse the string, These kind of you can Python small you can see here in Python small samples. You can do it, and you can practice it Python, because Python code is very much needed. So at least you people should know this language very well. So I will share the PPT today, and I will share the code. There is no code today, and Monday onwards we will go for only coding. Sorry for today, but I can't do. Okay, thank you everyone. Happy weekend. Any more questions? Anyone ask? Okay, okay, thank you. Logistic regression. Okay, logistic regression is following. Suppose we have a okay, I will explain it again. Um, Here is, yeah. Suppose we have a data loss. It's a loss regression. I did not explain. I just told that what is. I did not explain the loss or ridge regression. I just told you that when we are going to use it here, loss. Loss is the least. It is we are using here. Um, sorry, lasso. Yeah, lasso is actually lasso or ridge. Both are using when we have a data collinear, multi-collinearity in between the data. Okay, so these are the two methods. Either we are going for the ridge regression, or either we can go for the lasso regression. So lasso regression have some penalty options. Okay, so ridge regression have some penalty option because it internally. Okay, what the difference between two? Yeah, very correct. It is the difference in you can see we are in lasso regression we are giving the coefficient 0, because suppose one x2 is not needed, so the coefficient should be 0. So we are penalizing in this way, we are making coefficient 0. And ridge regression, we are just penalty, we are adding here one lambda beta 2, we are adding here. So we are considering in this way, you can understand in this way. uh, we have one in ridge regression we have a penalty option, and here in lasso regression we have some m3. Suppose few coefficient which are not useful, we are putting into 0 coefficient. So in this way we are uh, but the idea behind is both uh, lasso regression or regression, we are using it for regularization technique. It is calling under regularization technique. And when we have a data internally independent variable or internally dependent, then we are using it. Okay. uh, don't, if you can speak in this till in this few lines also, they will consider that this is okay for you. And I will share this so that you can use it. Okay, thank you. So sorry for today, but Monday onwards I will go for the practical only. Okay, thank you, happy weekend.